good morning, students. We're going to start the class now. So, in the last class, I just started with numericals and problems. So, we discussed one problem. So, the programming approach we use for solving the English programming. Okay, so same thing I will go to start. So, the second problem I want to solve and get it done today. Okay, so we'll solve our three problems in today's class so that we can find it out. Okay, so at the end, I want to have some instructions to people. So once I just before I just complete 10 minutes before the ending of the session, so I will just I want to talk to you people regarding the internet test. Okay, so I will discuss that later. Okay, so I want everybody to mute yourself. Okay, so we're going to have a session on how to solve the problems in today's. Okay, now I will start sharing you the problem statement what we have. I hope everybody is having a notepad and a calculator. Okay, so please start. We are going to start the problems on solving the problems on linear programming using the dynamic programming approach. Okay. Okay. As we solve the problem. Yeah. Can you see the problem statement, students? Can you see? Someone can unmute and you can see. Can you see that problems?
Yes, sir.
Oh, right. So we're going to start it now. So please take a notebook and a pen and calculator. So the same approach I will go to explain once again. And next problem you have to solve it and you have to get the answer. Okay. So I'll go to take. So please note down the question here. So here, yeah, the problem is maximize z is equal to 3x1 plus 4x2 and subject to the constraints 2x1 plus x2, 2x1 plus x2, which is less than or equal to 40, and the second constraint is 2x1 plus 5x2 less than or equal to 180. I want everybody to note down this problem and simultaneously you should start solving the problem also. Okay, next problem I want everybody to show the problem how you have solved and you have to show it in your video and you have to get it done, right? Yeah. So what last class I discussed how to approach this kind of problems when you want to solve. Most important thing is the number of decision. How many number of decision variables are there in this problem statement? So when you look at the problem statement with the objective function and the constraints, there are only two decision variables. One is x1, another one is x2. So with the number of stages, so because we're going to approach going to use sub-optimization technique or backward recursive approach for solving this LPP using dynamic programming approach. So therefore, first we need to, once you know or once you identify how many number of decision variables are there, next thing is we need to get how many number of stages is required to solve this problem. So the number of stages required will be always directly proportional to the number of decision variables. Okay. So since the number of decision variables is 2 here, so therefore the number of stages is also required is 2 in this case. So that is The stage 1 will be assigned to the decision variable x1 and the stage 2 is assigned to the decision variable x2. This is what we are supposed to do it. Okay. So there are two stages. So for first stage, we will going to assign the decision variable x1 and for the stage 2, we will going to assign the decision variable x2. Okay. So of course, we are using the backward recursive approach over here. So therefore, we will go into the resources. So you have to list out the resources similarly how we did for the last problem or the previous problem. So B11 is the resource 1 consumed in the stage 1 and B21 is the resource consumed in the stage 1. So similarly, just take B12 is the resource 1 consumed in the stage 2 and B22 is the resource 2 consumed in the stage 2. So like that you can get the resources which are consumed in the stage consumed, what is the resource consumed and in which stage it is been consumed. So just like you can just give the resources what we are going to consume and that will be used for getting the optimized values of x1 and x2 at the end. Okay. So now, so similar procedure how we did in the last problem. So first you get the recursive function for the stage 2 by considering the variable which we take it as f2 and the second one is f1. So recursive function for f1 by considering the variable x1. So since we are using a backward recursive approach, so first we have to start the last stage, that is second stage first, and later onwards we will go into group stage 1 and stage 2 together. Then we will go to total optimization of the. So first we have to consider the last stage of the process. One is that is the second stage. So therefore F2. So F2 is the for stage 2 considering the variable x2. So when you put the function over here, the objective function, the second stage will consist of an objective function of x2. Okay, so we have to maximize. So therefore, the function f2 will be as maximize for x2 and here the value of x2 lies between. Okay, so the value of x is going to be x2 less 0 and b12. So b12 is the resource 1. Okay, five x2. We have 5x2, which is less than or equal to raised to 0 and b22. Okay, so this is the value what we are going to take it for the that is stage 2. Okay, so now to maintain the feasibility, x2 should be minimum. X2 should be minimum, that is b12 and b22 by 4. 5. The above objective function so 2. It is the 4 minimum of b12. So b12 will lie between so x2 0 lies between 0 and b12 plus 5x2 lies between 0 and b22. So therefore, now to maintain the feasibility, so x value should be off. So it should be the value should be a minimum value of between b2 and b2 5. The above f2 is equal to minimum of value x2. Minimum of value x2 will be I or b2 by 5. This is what we modified the second recursive function f2 in this case. Okay, so therefore the value, the minimum value of x2 or x2 value will be the minimum of these two values. So whichever the minimum value we are going to get out of b12 and b22 by 5, that will be considered as the optimum value for x2. So this is the first stage of the problem. We'll move to the second stage here. So we will going to consider the the stage 1 and stage 2 both. We're going to sub-optimize the entire system by just grouping the stage 2 and stage 1 combined together and so for that, we have to consider the stage 1 where we have x1. F1 is equal to maximum of, which will be a maximum of 4x1 plus 4. That is the same objective function what we had in the problem statement here. So F1 is equal to 3x1 plus 4. X2 should be written in the form of the minimum value what we have. So that is B11. So that is B11 is the resource minus 2x1. So to where we are going to get 2x1? So this 2x and 2x1 both are in the constraints here. So in the two constraints, they are going to get. So B1 minus comma B21 minus 2x1 by 5. So this is how we are going to write the recursive function for stage 1. This is a very important step. So be careful with writing this recursive function for stage 1. Okay. So now this value of x1 into the that will be between 0 and b1. 0 and b1. Okay. So this is the constraints or the values of 2x1 or x1 between these two values of b11 and b12. This is the stage 1 is the last stage because we have two stages here. So stage 1 is the last in the series of the backward recursion. So therefore, what we will do, we will go to assign the values for b1 and b2. So b1 will assign the values of the first what it is given on the portion of the first constraint, and then b2 the value of the errors of the second constraint. Therefore, what we are doing here is, so b11 is equal to 40, okay, and b21 is equal to 20. This is what you will go to assign the values. So once you assign the values over here, so again you will go to modify this recursive function f1. So f1 will become maximum of 0, 2, 1, 4 of 0. Which is less than 2x1 lies between 0 and 40, and 2x1 lies between 0 and 180. So we are substituting the values of b11 as 40 in this expression and b21 as a 180 in this expression. So now again we will go into writing the expression by substituting the values of b11 as well as the b21 in this way. Okay. So this is how we are doing here. So now similarly, of course, just simply over here, x1 less than 40 similarly. So 2x1 less than or equal to 180 means x1 less than or equal to 90. So this is how we will just rearrange or simplify the expression. Now, once we get this expression, now we have to take, so in order to make the feasibility, so we have to consider the minimum range for the variable x1. So there are two things we have in here. The x1 lies between 0 and 20, x1 lies between 0 and 90. So in order to maintain the feasibility, so the value of x1 should be minimum. We need to select the range of values such that x1 will be minimum. Okay, this is how we will go into just choose. So once you just choose the range, minimum range for the So now, this is equation what we are going to do. So in making use of this expression, we supposed to take the minimum or optimum values of x1 and x2. So this value value of x1 lies between 0 and 1. So we have got x can be 0 and it can be 20. So hello, can you hear me? So, my dear students, hear me? Can you hear me now? Hello? Can you hear? Can you hear me, my dear students?
Yes, sir, I can hear.
Can you hear me now?
Yes, sir, it's audible
Hello?
now.
Okay. Some network problem is there, yeah. Okay. I will just start it now, please. Continue. Hello? Hello, my dear students, please unmute and you can you hear me now?
Yes, sir.
Okay, I'll just continue. Yeah. So this is the problem what we were solving now. So I want you people to get the values of x1. So substituting the values of x1 is equal to 0. So you can start solving this problem. Okay. So when you put x1 is equal to 0, so it is just a trial and error method. What you're supposed to do. So this trial and error method we're going to give. So you have to substitute the values of x1 is equal to 0, x1 is equal to 1, like that you keep on just try with the values and you're supposed to get the value of f1. Okay, so f1 you're supposed to get the maximum value. So that you have to check it by trial and error method only. Okay, by substituting the values from x1 is equal to 0 to x1 is equal to 20, less than 20. It should be less than 20 or equal to 20. Till there you have to check the values. Okay, so now what you do here is when you put the value of x1 is equal to 0. So when you put x1 is equal to 0 in this expression, so x1, if you put x1 is equal to 0, now it will become 3x1 is 3 into 0 plus 4, and the minimum of 40 minus 2 into 0, comma 180 minus 2 into 0 into 5. So you will going to get, when you substituting the values of x1 in this case, and we will going to get this is 0, 4 of minimum of 40 and 36. So 2 into 0 means 40, means it will become 36. So 36 we will going to take, and 0 plus 4 into 36, it is 144. So in the similar way, you have to just substitute the values of x1 as 1, x2 as x1 as 2, like that. If you keep on changing the values of x1, so then you will going to get the values of f1. So correspondingly, you can get the values of f1. F1 should be maximum value. So like that, if you try trial and error method, so we have shown it is for only three values here. X is equal to 2.5 is also possible. In between, you have to try x1 is equal to 20. They have seen. See, for 20, they have got 60. So minimum value is 0 and the maximum value is 20. So first you do that minimum value and maximum value, then you can come to know whether the trend is increasing or decreasing. So when you just put the value of x1 is equal to 0 in this expression, so x1 is equal to 0, the f1 value was 144, and if you put x1 is equal to 20, so you will going to get the f1 as 60. So means the value, if you keep on increasing the value of x1, the f1 is decreasing. So that is a decreasing trend what you can see. Then later onwards, after you can just randomly you can take the values of x1. So put f1 as x1 is equal to 5, x1 is equal to 10. Then look at the trend how it is moving. Okay. So then if it is x1 to x10 it is less, means again you can go back to So what you are doing? So because only at some particular, only for one value of x1, so you will going to get f1 will be maximum. So you have to identify that value, which is the value for x1. The f1 will become maximum. So that value you have to identify. So here we are getting for x1 is equal to 2.5. So we are getting f1 as 147.5. So that is the maximum value for f1 what we are supposed to get for this problem. Okay. So when you put x1 is equal to 2.5, so in this expression, so correspondingly, what will be the value, the minimum value of x2? It is 35. Okay, so therefore, so f1 is 147.5 is the maximum value you are getting. For this 147.5, what is the value of x1? It is 2.5. And what is the value of x2? It is 35. Okay, so therefore, see, look at here, x1 is 2.5, x2 is 35, f is 147.5. This is the final answer what you are supposed to give it to us. Okay, yes, you have to get the answer. This is the one thing what you are supposed to be very careful while you are drawing this problem. Okay, so you can try these problems and you can solve, because what I'm talking is the problems are very important from the examination point of view. Okay, so please try this problem. So I want you people to get this problem and note down this problem, and you can get the solution problem. So I want everybody to note down this problem now. So use dynamic programming problem to solve LPP. For that, yeah. So please unmute yourself, my dear students. Please unmute. Yeah. So could you able to follow the problem what we are solving now?
No, sir.
Okay, so you can because it's a very important problem from the examination point of view. So you will have around 8 to 10 marks. One problem definitely there in the dynamic programming problem. Okay, so I want you people to just solve this now. Just try this problem and please just show to me how these answers, how you can go to get these answers. So I want you people to solve this now. So I want to solve you individually and the same procedure how I have done. Same procedure you can go, and where you struck, you can just stop me and you can just ask me and you can get the things done. Okay, so please look at this problem statement. I will just dictate this: maximize, maximize z is equal to x1 plus 9x2. Maximize x1 plus 9x2. Maximize z is equal to x1 plus 9x2 subject to the constraints. First constraint is 2x1 plus x2. 2x1 plus x2 less than or equal to 25. Less than or equal to 25. And second constraint is only x2. x1 is not there. x2 is less than or equal to 11. x2 less than or equal to 11. In the second constraint, there is no x1 variable. Only x2 variable they have given. x2 less than or equal to 11. Yeah. How do you proceed for this problem? First, what you're supposed to do, you have to check out for the decision variables. What is the decision variable in the objective function? So in the decision variables in the objective function, there are only two decision variables, x1 and x2. So please write down. Please write down. The first step is note down the objective, the number of decision variables. So based on that, decide how many number of stages you want. How many number of stages you want. So please try, please do. Otherwise, it's very difficult. I am telling you. Just simply, I will be keep on explaining and you just simply it means it's very difficult. I expect everybody to do this. Okay, so one problem at least you just have practice of your own, then it will be easy for everybody. Okay, so now, so number of decision variables is x2 because when you look at the objective function, so it consists of only x1 and x2 terms. So therefore, the number of decision variables will be x2. And based upon the number of decision variables, the number of stages. So since the number of stages is equal to the number of decision variables always. Therefore, number of stages is also equal to. So generally, you will have only two stage problems only, not more than that you will going to get it. So if anything is there, then you will going to discuss that later. Okay. So stage 2, there are two stages. Stage 1, which is assigned for the variable x1, and stage 2, it is assigned for the decision variable x2. So those two things you're supposed to be very careful. I hope everybody is solving there. Okay. Next, write down the resources. B11, B21, B12, B22. So all these things will remain common, no change. So for all the problems, these things will remain common. But the only thing is the function will go into change, the objective function will be changing, the constraints will be changing for it. So based on that, you are supposed to determine the values of x1 and x2. First write down B11, B21, B12, and B22. Okay. Next is write down F2, recursion function for stage 2 by considering the variable x2. If you find any difficulty or if you find any clarification, you can stop me. Yeah, Sandesh, any clarification?
No, sir.
Just proceed like that only. F2 and F1 you write. Because one problem if you solve, then you will get a confidence how to go about. Because next I am going to start with an non-linear programming problem. How to use dynamic programming for coaches for non-linear programming problem. I want you people to just have a confidence in solving any kind of LTP problem. So I just given two problems as an example. I want you people to solve this problem of your own. F2 recursive function for stage 2 by considering variable x2, and F1 is the recursive function for the stage 1 considering the variable x1. So these things you just keep on writing. Next you write F2. F2. Yeah. Anybody can tell what we are going to write F2? F2. What is F2? How do you write F2? Function F2, how do you write? Mithun?
F2 is equal to 9x2.
F2 is equal to
9x2.
maximize 9x2. That you don't forget. Max 9x2. Okay. So then what about the constraints for the x2 value? Anybody can talk. Sandesh? Sukrut? Danush?
0 less than x2.
X2 lies between
0 and b12.
0 and B12. Then
0 and bt2.
0 and B2. Yes, that is the one. See, I will going to repeat it. So the recursive function f2 can be written in terms of x2 in the form of maximize 9x2, and below the maximum the constraint for x2 is x2 lies between x2 less than or equal to 0 and 0, less than or equal to x2, which is less than or equal to b12. That is x2 lies between 0 and the second is, so this will go to on the constraint what we have given. So the coefficient there you have to add the coefficients also for the x2. So in the constraint number one, so what is given in the problem statement is 2x1 plus x2. So that x2 does not have any coefficient, right? So therefore here also we are going to write x2 less than or equal to b12 in the first constraint. And the second constraint when you are writing in the F2, so look at the second constraint in the problem statement. Again, the x2 does not have any coefficient. So therefore, only x2 lies between 0 and b22. So when you just look at the previous problems, the x2 will have a coefficient, and we also added the coefficient in just writing this. So be careful. This is the common mistake the students will do when they are solving the problem. Okay, so coefficient should also be added when you are writing the recursive function, that is f2. Okay, so that is the one thing. Okay, next. I hope everybody has got this. Any clarification, anybody? Just writing the recursive function f2 in terms of x2. Okay, so please look at the coefficients in the constraints. Coefficient for x2. Coefficient for x2. If any coefficient is there, that also should be added or it should be included in this expression. Okay, next. To maintain the feasibility, x2 should be minimum. So to maintain the feasibility, x2 should be minimum of b12 and b22. That you write here. And the above objective function is modified as follows. So we're going to write the above objective function in this way. So how do you write that? Yeah. Anybody can tell how do you write that? When how do you modify the objective function f2 is equal to
9 minimum b12 comma b22.
Very good. Yes, that's it. F2 is equal to 9 minimum of B12 comma B22, and X2 should be minimum of B12 comma B2. That's it. Very good. That's it. So this is the first stage. Okay. So now move to the second stage now. So recursive function for stage 1 with respect to the variable x1. Recursive function for stage 1 with respect to the variable x1. So write f1 is equal to yeah. Anybody can tell the expression what is f1 is? Anybody can tell that expression f1, recursive function f1? You can got it?
Sir, maximum
Ah,
x1 plus 9 minimum
ah,
b11 minus 2x1 comma b21 minus 0.
yeah, B21 minus 0 is not required. B21, that's enough. And what about the constraint? Constraint for x1. Constraint for x1. The constraint will be 2x1 lies between 0 and b1. 2x1 lies between 0 and b1. So since the stage 1 is the last in the series, the backward recursion, so therefore you can assign the value of b11 as 25 and b21 as 11. Please put that values. So since the stage 1 is the last in the series, backward recursion, so therefore b11 is equal to 25, which will be the RHS part of the first constraint, and b21 is the RHS part of the second constraint. Now substitute those things in your first that is F1 equation. So you can see this. Just substituting the value of x b11 as 25 and b21 as 11, that is 11, and the rest of things is you can get the equation. So what equation you will going to get? Maximize x which lies between 0 and 12.5, x1 plus 9 minimum, 25 minus 2x1 comma 11. So this is the final equation. What you will going to get. Okay. So you can substitute the value of x1 starting from 0 to 12.5, and you can get the what is the optimum values for that function. Okay. So this is what I wanted to convey in today's class. So I just last 10 minutes I want to talk to you regarding okay. My dear students, just please keep your book and pen aside, and please unmute yourself. Everybody, I want everybody to unmute. Yeah. So one important information that I need to convey at this point is, so your first internals will be conducted online. So online from 2nd, 3rd and 4th May. Okay, 2nd, 3rd and 4th May. So you will, all 5 subjects will be conducted for the first internals. So you will have second, maybe you will be having 2 tests. Third, you might be having 2 tests, and fourth, you might be having 1 test. Still, you will go to get a detailed timetable and everything. But of course, it will be in a staggered way. Timing will be very staggered way, starting from morning 9 to night 9 o'clock. You might be having. Okay, so this this is the first time that what we are conducting an online test for you. So what according to the principal and dean academics and HOD, the instructions what we have got, it should be of multiple choice questions. Everybody can hear? Everybody is hearing? Can you hear me, everybody?
Not properly, sir.
Now? Hello?
Yes, sir. Now we can hear.
Yeah. See, you will have first internal test from second, third, and fourth. Second, third, and fourth. Okay. So all 5 subjects test will be conducted. This will be considered as the first internal assessment test. Okay. So here, what we do here is, according to the instructions from principal, dean academics, and HOD is, this test will be conducted for online and it will be of MCQ type, multiple choice question type. That means you will have one question and we will going to give 4 answers for that and you have to select which is the correct answer for that. This is what we call it as an objective type of question. Okay. So for this, we need to have what syllabus we supposed to be given for. Okay. So that's what I wanted to have the discussion here. So what shall we do? We will give module 1 and module 2 completely for the first internals, or shall we do module 2 and module 5? Which shall we will start? Okay, you can talk to me. You can just interact with me. So shall we do module 2 and module 3 what I covered till tomorrow?
Yes, sir.
Yes, sir.
Module 2, yeah, shall we add module 1 also?
1 and 2 is better, sir.
Now 1 and 2, why I am not interested? 1 is not, I am not interested because I think you people has to give the presentation.
Yes.
The technical seminar I have given for you people still it is not happened. So many of the students might not be having the material to study those things. So that's what just thinking of why don't we start with the module 2 and module 5. Module
Okay.
5. Okay. So
Yes,
module
sir.
5 what? Module 5 I don't add these problems also, only till theory what I discussed. Okay. So module 5 only till theory what I discussed I will going to include for the first internal test, and module 2 will be completely there.
Okay, sir.
Module 2 completely, and only dynamic programming, that is module 5 what I just covered till the theoretical part. So problem I don't include this time. So we will see in the second instance if possible we will going to add this. And first module I don't want to add for this now because still many things we are not covered because you people has to give the seminar on those things. So still it is not happened. So I don't want to take that portion for the syllabus. I will take module 2 and module 5 for the first internal test. And module 1 we will see the second internal. By that time we will have a seminar and that we will go to complete it. Okay, not an issue?
No, sir.
If you have any issues, you can talk to me because you will have a test from Saturday, Sunday, and Monday. 3 days you will have a test. This will be considered for first internal test, first internal marks. Take it very seriously, I am telling you. So it should be an multiple choice question or questions, and we're going to set 30 questions. 30 questions will be given for you, and you will be given minimum to 30 to 45 minutes time. Okay, so everybody should log in a common platform, what we call it as a Moodle. Moodle platform is there. So everything we're going to just demonstrate later. Moodle platform you have to answer because that Moodle platform server can take only around 180 to 200 students at a time. So therefore, so you'll be having in a staggered timings. So not everybody will be having at the same time. Different semesters, different sections, they will have us in a different staggered timing test will be there. So that detailed timetable you will going to receive it very soon. Okay. But before that, so what is the pattern we are going to have it for the test? It is an MCQs and the syllabus is module 2 completely. That is optimization design problem formulation, and second one is the optimization concept. That is the module 2. And in module 5, dynamic programming, I include in the theory part. No problematic part I will go to include. Only till theory part I will go into add. So totally 1.5 modules will be there for your syllabus and get prepared. Okay, so materials and everything I will go into upload it in the Google Classroom. Already the module 2 I already uploaded everything, PPT and everything I uploaded. So prepare for PPT, that is more than enough. Okay, and
Actually, not sir. In the Google Classroom.
yeah,
In the Google Classroom, visible, sir. The what you uploaded.
yeah, it is there, no?
It's not visible, sir.
Not visible, no?
I mean, it's
No,
not there, sir.
no, it is there. I uploaded. There is, just last week only I uploaded, no?
No, sir. There is
Not
no PPT.
Not there.
Only module 2, part 3, part 4, part 5 is there, sir.
Yeah, that is the PPT, right? Module 1, that is what the part 1 I have given already, no?
There is no PPT there, sir. Module 1.
Not there.
No, sir.
Okay, I will just module 2, part 2, part 3, everything is there.
Part 3, part 4, part 5.
It is there.
Part 1, part 2, yes, sir. Part 1 and part 2 is not there.
Part 1, part 2 is not there. I will just upload it, no problem. Today I am going to upload it, all those things. And dynamic programming also, so I am going to upload it today. Everything will be uploaded today. Okay, so please prepare for the test. Take it very seriously because no other test will be conducted. So only you will have two tests, three tests, or two tests I think you might be having. So this is the first test you will going to have. Okay, take it very seriously and you will have multiple choice questions. 30 questions will be given and you have to answer within 30 to 40 minutes. This is the only time limit what they are given. Okay, so please prepare. Okay, so you are going to get the timetable shortly. So only during that time only you have to log in and you have to answer the questions. Okay, so it will start from 2nd, 3rd, and 4th. All the 4 days will be there. All the 3 days you will have a test. So timings you are going to get it issued. Okay, so if any clarification is there, you can ask me before I just wind up the class. Anybody having any clarification?
No, sir.
Okay, so you are going to receive the timetable shortly. Soon you are going to receive the timetable, and this is the pattern what I will going to give. Okay, so please prepare, and if you have any doubts or any clarification, when you come for tomorrow's class, you can just clarify your doubts. Okay, pa? Clear?
Yes, sir.
Okay, thank you very much.
Yes,
Thank
sir.
you very much.